make mistake while solving lasso regression numericals, especially with the sine function, and that completely changes the answer. In this video, I'll solve a full problem step by step and that clear that confusion. Now let's first take a data set. We predict churn using all these things, calls per day and data usage, contract length and support classes, and we'll solve it using lasso regression with gradient descent. Before solving, let's understand the correct flow of this, where most people go wrong. So step 1 will be our hypothesis function, where this formula is used to predict, that gives the output of the like it predicts the output. Then we'll be going with the error. We'll be finding the error. If error is greater than 0, then the prediction is too high. If error is less than 0, the prediction is too low. We'll be finding the cost function. As you can see the formula here, this is the error, this is the error, and this one will be L1, which pushes the weights towards 0, and here the gradient will be there. Next comes the gradient. In this gradient we have this one, which is the error again, the same thing that we have found in the step 2, that will be considered along with the x values, and lambda into sine function will be used here. This is the most important part where people get confused. Then we'll be doing the weight update rule. We'll be applying this formula. In this, the gradient will be coming again, the before step. So step by step you have to go. If you miss this step, you can't do here gradient again, you get confused. Here alpha is the learning rate, and then we'll be updating. So like this we'll be using it, and also we'll be finding the bias of this. So you will be understood more clearly when we solve the problem. This is exactly the flow that we are going with. So the most confusing part is sine. Sine is not taken once for all the weights. Whatever the weights we get, we will not take the sine equally. We'll be taking for each weight. For example, if it is greater than 0, the sine will be considered as positive. Less than 0, then it is negative. And if it is equal to 0, then we'll be considering the sine value to be 0. So this is our data set. Let's go with the row number 1. So here this is our row number 1, 15 comma 5.2 comma 24 comma 4. This is our row number 1. Let's go with the iteration number 1. So here the target value churn score is given as 0.2. We'll be assuming theta naught, theta 1, theta 2, theta 3 and theta 4 initially to be 0. Alpha also is been assumed, that is the learning rate, 0.001, and lambda is taken as 0.3. Okay, so the first step is we'll be finding out the h of x. As I have told you, h of x is theta naught plus theta 1 x1 plus theta 2 x2 plus theta 3 x3 plus theta 4 x4. So here everything is 0, then eventually we get the h of x is 0. Then we'll be finding the error. As you can see, the error formula is h of x minus y. So h of x is 0. So 0 minus 0.2. 0.2 is the y value. So we'll be considering this, and we'll be getting the error as negative, minus 0.2. So error is negative means it is too low. Okay. Then we'll be finding the update of the theta naught. So here what do we do is, so while updating theta naught, this is the initial theta naught. Like I have told you, theta naught initially is 0. So new one we wanted to find. So new one is equals to old one minus 0.001 is our alpha. Okay, alpha into minus 0.2, that is our error. So we'll be taking this formula. Okay, for the new updated weights, we'll be taking this formula as you can see it here. So we'll be solving it. For the update, what do we do is we'll be using this formula. As I have told you, for update we'll be using this particular formula. In this formula, this is basically your error after finding error, and this is alpha. As you know, this is new updated one, and this is the thing L1 that you will be finding. Sine will be considered according to the weight. Don't get confused. As you have seen this first iteration, it will be new, and for second iteration it will be more clear. Okay, keep watching. Wait. So here we'll be finding theta 2, theta 3, theta 4 in the same method. After that, these are the theta, new weights of these things. All weights are positive. after one iteration. Okay, this is the whole process of iteration number 1. After that we got all positive values, then sine of theta 1 will be positive plus 1. As I have told you here, it is according to the weights. If the weights are positive, that is greater than 0, then sine will be considered to be the positive. Whenever we are finding, we'll be considering sine value as positive. Now for iteration 2, we'll be taking the second row. As you can see in this data set, the second row is 8, 12.5, 12 and 3, and the churn score is 0.7. So you can see this, these are the x values and this is the y value. H of x will be 0.126. Okay, after finding h of x, we'll be taking error value of it. We got error value as minus 0.574. That means it is in negative. So we'll be updating the weights. For that, we'll be considering the gradient first. What do we do? Theta 1 is equals to error into x1. As you have seen this formula before, right? Error into x plus lambda into sine of theta. Now sine of theta will be positive. Why? Because the new weights, whatever we got after iteration 1, were positive. So we'll be considering it to be 1. So 0.3 into 1. We'll be taking directly 0.3. Okay. After that, we'll be getting the new theta 1. This is it. After that, we'll be doing the update of that particular theta 1. Okay. So update, as I have shown you, this is the formula. So this whole thing is already been calculated here. After that, we'll be directly keeping inside this formula. So theta j minus alpha into the whole thing, the gradient thing. This is called as gradient. We have found it already. So first we'll be finding the gradient, then we'll be keeping it inside the update formula. So like that, we'll be finding all the gradients for theta 2, theta 3, theta 4. Then we'll be doing the update. While doing update, for the update step, weight update rule will be used. As you can see, theta j is equals to theta j minus alpha into gradient. Exact formula is been kept here. For theta naught, we just have used theta old minus neta into error. The error that we have got here. Okay. Only for theta naught, because it is a bias. So for bias, we have used like that. For the other weights, we have used the old weight minus neta into gradient. Whatever the gradient that we have calculated. Like you can see here, theta 1 gradient was minus 4.292, right? So the same thing that we have considered, minus 4.292. We got this one. Okay. Then for theta 2, again same thing. Theta 2 gradient was minus 6.875. We have taken minus 6.875. That means neta into gradient. Old one minus neta into gradient. We'll be getting the updated weight. Like that, we'll be doing for all the things. As you can see, after iteration 2, these are our new weights along with the bias also. For calculating the bias, we have considered error. Okay. We have considered the error itself as the thing because it is bias. Next, for iteration 3, we have taken the third row and the target value. Same thing we have done. H of x we have found, then the error. After finding error, okay. Let's see here. The weights are positive. Okay. So the sine value will be positive. So this lambda into sine function, whatever the formula that is there, this sine into lambda is 0.3, and the errors are errors. We have found the error of this, here it is, and sine value taken as positive. So we did not even write anything because positive, that is plus 1. Everywhere we just have taken 0.3 and we have done this. Got it? Error into x values, error into 20, error into this one. Like every weight we'll be getting the gradients. After getting the gradients, we will be doing old weight minus neta into gradient. For this one thing, because it is bias, we'll be considering the error value. For the other things, we'll be considering the gradients of this particular things, right? We'll be getting the updated weights. Here the updated weights are minus. So for this, we'll be taking positive because it is positive. Here negative. So sine value will be negative. For each and every weight, we'll be considering the sine values for the next iteration. I guess you have understood, and this is about the sine. Don't get confused in this because the most confusion lies in this particular thing. Thank you.